Welcome back, everybody. How's it going? It's going. So I've heard from several of you who started working on a homework 2. Can I offer any help or answer any questions about that? Lindsay. Yes. Rather than trying to get them for each specific thing, focus on which variance component each fixed effect should be targeting. But since they're all within one model, I'm not asking you to evaluate the contribution of each separately. Yes.
I have question
16. Yes.
So this p-value, is it p-value associated with the question 15?
Yes.
But I got right question 15, but I got wrong question 16.
You have the right -2 log likelihood difference, but the wrong p-value. Make sure that you are using the right degrees of freedom. And I will give you a hint. Those of you who are using my fit test macro in SAS to do -2 log likelihood comparisons, SAS, if your variance component comes up non-estimable for a slope, it does not count that as part of your degrees of freedom, even though it should. So it might be returning the wrong degrees of freedom in that case. So if you are going from a random linear to a random quadratic, or fixed quadratic random linear to random quadratic, how many terms have you just added? We've added the random quadratic, right? And 2 covariances with the intercept and the linear slope that was already there, so it should be 3. It should be 3. SAS may report it as 2 if the random quadratic variance goes to 0. It doesn't count it, but it should count because it's tested. Yes. As an FYI, I forgot to mention last time, I put a link on the main page up here to a document, a text file actually, that has my macros. So if you don't have a copy of them, you can put them here. So I have total R-square, pseudo R-square fit test, and then I also have a pseudo R-square and fit test within Proc-Glymics, which we will use later in the semester. So if you ever need to access those, they are on here. All right. Any other questions? Okie dokie. Then we were talking about the joy of time-varying predictors, right? Should we do a little review? I should assume you don't remember everything perfectly at the beginning of class. I should go ahead and assume that. Even if you do, doesn't it feel good to be like, I knew that. I got that one. We all deserve a win. We do. So let me start on slide 3 here and hit a couple before we go into a new example to go back over these concepts. So time-varying predictors, level 1 predictors, time things within this context, but level 1 predictors broadly construed all have these properties. To the extent that they have level 2 between-person variance, they can show a between-person effect. To the extent that they have level 1 within-person variance, they can show a within-person effect. Those effects need not be the same, and in fact, most of the time they won't be the same. So the question then is, how do we set up the model to differentiate the effect at level 2 from the effect at level 1? So just to review, you can always run an empty model to get an intraclass correlation for your level 1 predictor to find out how much of its variation is at each level. To the extent that the intraclass correlation is greater than 0, you have to worry about a level 2 between effect. To the extent that the intraclass correlation is less than 1, you have to worry about a level 1 within effect. So we started with an example just looking at between effects and within effects last time. The idea that if you have more of your predictor than other people, you may have more of your outcome. If you have more than usual of your predictor, then you may have more than usual of your outcome at that same occasion, or perhaps at a lagged occasion, however you want to set it up. but these are two different ways that the variables can be associated over time. One is on average, cross-sectionally, and the other is at a particular occasion, longitudinally. So we set up the model then using group mean centering, or person mean centering is what it should be called in this context. And it looks like this. So at level 2, we're taking our time-varying predictor, we're computing the person's mean across all of the occasions. We're taking that person mean and centering it at a constant so that 0 is a meaningful value. If 0 is already meaningful, leave it alone. It's fine. What the constant is only a difference in interpretation. There's no way to really mess that up. So if I pick the sample mean, for instance, as my level 2 constant, then having a high value of person mean x mean I have more on average, than other people. And if I have less, then I have less than average. Level 1 then, this is centering at a variable, not a constant. And that makes a big difference. So we take the original level 1 x, we subtract the person's mean, whatever that happens to be, and the new time varying predictor has only level 1 within person variation as a result. So if I have a positive within person x value, I'm higher than usual, whatever usual happens to be for me. Whatever usual happens to be is already been captured by person mean x in the level 2 model where it belongs. So this method of person mean centering renders these two new predictors orthogonal, and each accounts for its own effect at its own level. Person mean x only has between person variance. It can only have a between person effect. Within person x only has within person level 1 variance. It can only have a within person effect. And that is why I like to set up models this way for longitudinal data, because the interpretations are clear and it's hard to screw this up. Okay. Which one of these predictors could potentially have a random effect? Which predictor's effect could potentially vary over people? – 50-50 choice here. I heard level 2, I heard within. Should we take a vote? Votes for level 2, couple. Votes for level 1, about half and half. I'm going to side with the level 1s on this one. The within person effect can vary over people. The between person effect can't vary over people because each person only has one value. The between person effect could vary over groups if people were nested in groups though. Level 1 can have a random effect over level 2. So the effect of within person X, the effect of having more of this than usual, the extent to which having more stress than usual makes your health worse than usual, that can vary over people. But the effect of being a person who has more stress on your average level of health, that can't vary over people because each person has only one value of person mean stress and only one value of person mean health. So the purple, the level 1 can potentially have a fixed effect, a random effect, either or both. The level 2 can only have a fixed effect in 2-level models. All right, so we looked at equations, we looked at pictures, and just to remind you what we're doing here conceptually, in the same way that we start off all longitudinal models for an outcome with an empty model so that we can partition the between from the within variance, we're trying to do that same thing but by brute force instead. We are creating observed variables, or what I call boxes, observed representations of the between variance and the within variance. So the person mean at level 2 is meant to mimic the random intercept variance, and the within person variance, the within person X at level 1 is meant to mimic the residual. So there's a symmetry of how X and Y are being treated. We've split the level 2 part from the level 1 part, and each has its own job to do. It's just that the model is doing it via estimated variance components for the outcome, whereas we are doing it through brute force on the predictor side. The idea that we could let the model do both at the same time is the basis of multivariate models, or multivariate or multi-level structural equation models as they are known. And we will get to those later because they require different software. Okay. So any questions on the big picture stuff? Okay, do you want to see another example then? Why not, right? We're all here. You made the trek in 15 degrees to school. So we have then another example for you, example 3B. These are simulated data based on a real story. Here's the publication behind the real story. I took some liberties with the data, though, to make it behave exactly how I wanted. But this is an example of a fluctuation type study. We're studying type 2 diabetics, and the outcome is the next morning's glucose in a log metric because it's a very skewed variable. And we have about, how many people? 200 and some people, I think, measured over 21 days. Where we asked several things about their daily life, but the outcome, or the predictor we're looking at right here is negative affect, which I'm calling negative mood, and how the relationship between negative mood and glucose can be moderated by gender. That's my story here. So these data are available for you to play with if you'd like. I put that up for download, and there's also a spreadsheet that has all of the calculations that I'm doing in here. Let me find this one. I'll refer back to that. Show you how things came about. So we are creating the two variables right here that I just mentioned, person mean something and within person something. Now in this data set, I already had a column that is the person mean negative mood. How you get that information in your data depends on how it's situated. If your data are multivariate wide, where it's like time 1, 2, 3, 4 as separate variables, then you can just use a mean function and get the person's mean as a new column. If your data are already stacked long so that each row is a separate outcome, then you need a different function. In SAST, you can do it via proc means by person and then output a data set of person means and merge it back in. It's one line in Stata, I think. It's an eGen. Yeah, so it's easier in Stata, and I think it's easier in R too. That's one of the few things in SAS that's clunkier than other programs. In SPSS, the command, by the way, is called aggregate. That's the one I didn't know about, and I spent 6 weeks entering data by hand that aggregate would have done for me in 5 lines of code. So just so you know, do not compute the person mean yourself. If you're not sure how to get it, please ask, because the program is happy to do it for you. So in this data set, the negative affect variable is actually a latent trait score that I created from measurement models separately, and that latent trait was identified such that the mean was already 0. So I didn't have to center, and that's why I have a -0 here as sort of a placeholder for the idea that if your variable doesn't have a meaningful 0, then you're going to want to give it one. So this just reminds us that I have person mean negative mood centered at 0 already as my between person indicator. I then have my original time varying negative mood minus person mean negative mood, and that's my within person level 1 indicator. And note, I don't have a number at the end of my variable name because it's not centered at a number. It's centered at a variable. So what 0 means is that you are at your own average, whatever that happens to be. And we will disregard this last one here for the time being. And I already had a variable for gender in my data set, so I've called it sex MW, which helps me remember who's the 0 and who's the 1. In this case, men are the reference group and women are the 1. So the data are already set up so that the next morning's glucose is on the same line as the negative mood score, so I didn't have to do any rearrangement there. But I do want to know how much of each of my time varying variables is between versus within. So here is log morning glucose as my outcome in an empty model. Note the magical V-core option, which gives you the intra-class correlation in a matrix. If you don't have that, you can always get your intra-class correlation as random intercept variance divided by random intercept variance plus residual variance. That works out to be 0.69. So most of my variation in glucose is between or within? Louder. You know this one. Between. Most of my variation is level 1 or level 2? 2. Most of my variation is people or time? People. Okay. I'm drilling the vocabulary because this gets almost impossible to follow if these things aren't right there on the tip of your tongue. So people, level 2, between. Cross-sectional, time invariant. 70% of my information would have been there on day 1. That means the other 31% is within, level 1, longitudinal, time varying. Likewise, for negative mood, the predictor, I am decomposing its variance. It is 39% between. So that means we do have to worry about what its between person effect might be, what its within person effect might be, and to allow those to be 2 different numbers as needed. Okay, with me so far? All right, so person mean centering. I am putting in both predictors at the same time. Within person X goes into level 1, and person mean X goes into level 2. I have an equation here on the top of page 2, this right here. I can't highlight it because it's an object, but you can see my cursor, hopefully, yeah, that one. Rather than typing within person X, I'm showing by the equation exactly how it was constructed. It is mood TI, meaning time varying mood, minus the person's mean mood. So bar over it meaning mean, bar over what unit? I. So that embedded term then is the predictor, the one that I created. At level 2 then, in the model for the intercept beta 0, I've included a fixed effect for person mean mood, and again just using the -0 to remind you that it hasn't been centered at any new constant. 0 is the average for the sample. Right now I have a beta 1, which is going to be my within person effective mood. That is one single thing right here. Is gamma 10 a fixed effect or a random effect? Fixed, yeah, I'm going for the easy ones today. These are like softballs, right? And not even fast pitch softball. This is like the kind where you play in Parks and Rec where they're like, eh. Right? The kind where you're not allowed to have strikes or balls even, right? You're supposed to hit everything. That's the kind of softball we're playing. So yes. So what does it mean that I just have one term here without any subscripts for i's or anything on it? What am I assuming about my within person effective mood being fixed? It's constant. It's all the same. Everybody gets the same one. Yes. So I'm asking, is there an effect at all right now? Does how grumpy you feel on a given day affect your glucose the next morning? And on a given day reflects 2 different sources of information. How grumpy you tend to be and how bad today is. So on a given day is represented by 2 different variables in the model here. Within person negative mood at level 1, person mean negative mood at level 2. And I have one more piece of code here. Because this gets confusing quickly to have the same variable in the model under different adjectives within and between, this is my trail of breadcrumbs trying to help myself remind myself what things mean. So I don't need these first 2 estimate statements. These are just labels. I'm reminding myself that the fixed effect of within person negative mood here is the within person effect. The fixed effect of person mean negative mood here is the between effect. And if I wanted to know whether or not one was different from the other, that is a third thing we haven't talked about yet called a contextual effect. But it's just a straight difference between the between and within effects. I am saving some pieces of information from my model to do math on. out PM here, that gives me a data set. I have named that data set pred mood, and it has all of the information in my original data set plus a new column of predicted outcomes predicted by the model fixed effects. I'm going to use that to get me a total R square. I have saved the Cove parms table, which is this little piece right here, into a data set called Cove mood. I'm going to use that to do pseudo R squares. InfoCrit is my fit test, and I've saved this into a data set to test random effects subsequently. I had already saved Cove empty and InfoCrit fit empty from the empty model as a comparison. So then we have 3 fixed effects to interpret. All 3 are significant. My intercept, 4.9, is my expected log glucose for somebody with an average level of grumpiness when they're at their average. And yes, in the paper we did get to say average grumpy. One of the reviewers yelled at us for it, but we stuck by it, and it's grumpy. Because person mean negative mood is a mouthful, and everyone knows what grumpy means. As in, he's really grumpy, or don't make me grumpy. Between and within, respectively. So here's my within effect, and these numbers are tiny because the scale of this is a log, but it is significant and it is positive. So all predictors, you can interpret their slope starting with a for every 1 unit language, right? The trick to this is remembering what the reference point is. For every 1 unit in what? Well, within person negative mood is for every unit grumpier you are than your mean, because 0 is wherever you are on your average. So if I am grumpier by 1 on this scale, that day's glucose goes up by 0.01. Per unit grumpier than usual, the change in Y is 0.01. And I would say change because this is a within person longitudinal effect. You can watch people change back and forth across days in a longitudinal study. So within person negative mood at level 1, for every unit more grumpy than usual, your log glucose the next morning goes up by 0.01. And then person mean negative mood, this is a cross-sectional effect. For every unit grumpier I am than other people, my average glucose all the time goes up by 0.08. For every unit grumpier I am than other people, my average morning glucose goes up by 0.08 all the time. And part of the innovation in this study is that these sorts of mood health relationships had been shown between persons cross-sectionally, and there wasn't as much evidence for them longitudinally, so it was a big deal that we have this within person effect. So that was why it got to be part of health psychology. Now the last one here, the easiest way to explain what this means is to look at the numbers. 0.07 is the difference between 0.01 and 0.08. 0.07 is not 0. So 0.08 is more than 0.01. That's the easiest way to explain it. That is not the way people will talk about it in life, so I'll have a harder version of that coming at you later. But another way to think about it is that putting these together into one coefficient, as you would get if I just put in time-varying negative mood, that would be creating a coefficient that's going to be somewhere between 0.01 and 0.08 smushed together. So the fact that those are different numbers means that we do need to worry about having different effects at different levels. All right, how are we doing? With me? Okay, now those are significance. But I have a pretty big sample. I have like 200 people and 20 observations per day, so that's a pretty big level 1 sample size. How do I talk about effect size here? These are fixed effects. So do fixed effects explain variance? Yes. Now, which one? The short answer, the one that's in its line. So within person negative mood is level 1. That means which variance should it have explained? Residual, level 1. Did it? Here's my pseudo R-square macro. Just to review how these are computed, it takes the variance component from the baseline model and the variance component from the current model, and it says what it was minus what it is over what it was. So 0.03029 minus 0.03022 divided by 0.03029 is 0.002. So 0.2% of the residual variance. That's what I got, and it's significant. That's a lot of power. So then which kind of variance did the level 2 effect of person mean negative mood account for? What's left? If it's level 2, random something, that's good. One more word in there. This is random intercept. That's all we have in this data. And actually, I had previously went through a whole bunch of alternative covariant structure models, and compound symmetry, random intercept only, was sufficient. So that's why I stuck with here. So yeah, level 2 effect of between person mean negative mood accounted for 3.3% of the random intercept variance. So to put those in perspective, how much of the variance in glucose was due to level 2 between in the first place? Do you remember? %. So of the 69% of the variance in glucose that was between persons level 2, we have 3.3% of that accounted for by person differences in grumpiness. So of the 69% that was level 2, my level 2 predictor of person mean grumpiness accounted for 3.3%. Likewise, at level 1, of the 31% that was level 1 within persons, within person grumpy, being grumpier than usual, accounted for 0.2% of that. And if you want to put those percentages back together, that's where your friend total R square comes in. So I have the correlation here between the actual log glucose outcome and the one that was predicted from the model fixed effects, which at this point are just the 2 effects of negative mood. The correlation between the real outcome and the one predicted by the model is 0.15. If you square that, you get R square, which is 0.023. So that's my total R square. How much of the variation in glucose was captured by effects of mood? 2%. More specifically, we got 3.3% of the random intercept variance and 0.2% of the residual variance. So there's 3 different numbers I'm giving you there, and they're all complementary pieces of information. You don't have to give the reader all of them, but it can be helpful. In models that have a whole lot of different variance components to keep track of, I tend to just go with total R squared because it's one number, and anybody who's ever had a regression class can follow it. If you have specific hypotheses about what certain levels of effects should be at level 2 or 1 or within or between, that's where pseudo R squares are going to be more directly what you want to know. Now I have, this is ML that we're using here, so I can do differences in fit as a function of fixed effects if I want to. I could also do that as a contrast statement, so I have a -2 log likelihood for the difference in adding those 2 fixed effects, which is significant. So that would be an omnibus test for whether or not that total R square is different than 0. The 2 degree of freedom comparison, here done with a likelihood ratio test, tells me that total R square is different than 0. Okay. There's a lot of words coming out of my mouth. How are we doing, folks? Any of that you want to hear again or hear differently?
Can you say the part about once there's 0.2%?
Yes. So this one, that is the pseudo R square for the residual. That is the reduction due to the within person effect of negative mood. And the way I interpret that is, of the 31% of the variance in glucose that was originally within persons, the within person effect of negative mood captured 0.2% of that. It's a proportion of a proportion. So I have 3.3% of 69%, and I have 0.2% of 31%. And if you put that together as a weighted average, you get a total R square of 2.3%. Yeah, I said one extra point in there, but R square of 0.023, which is 2.3%. Okay. So I asked you earlier which level of effect could potentially have a random effect. And you told me, or we decided on, within person negative mood. So let's try that. So just like the first part of the time modeling was fixed time, then random time, same idea here. I have a linear effect of within person mood. Could I potentially have a quadratic effect too? Sure. I could do that one next, but I'm sticking with linear just for now because this is complicated enough. But I'm adding U1 to the level 2 equation for beta 1, which is the within person effect of negative mood. So I'm adding a random effect. I'm adding, does each person need their own, right? In adding my random effect, am I explaining variance or making a new pile? New pile! Yes. You like softball, don't you, Lucas? You're playing. Yeah, it's good to be right, right? Yeah, I'm building self-efficacy here. That's what we're going for. I never try to trick you without warning you first. But yes, random, everybody gets their own. So we're making a new pile. We're asking, does the model fit better if I make a third pile? If I take what used to be residual variance and I move it up to level 2 and I call it random slope variance for within person negative mood. So the within person negative mood fixed effect said that when I am grumpier than usual, my glucose the next morning is higher than usual. I'm now asking, does the extent to which that happens vary by person? Does one's reactivity to negative mood vary across people? Are there individual differences in the effect of being grumpier than usual on log glucose the next morning? And here are my covariance parameters. Do you guys remember how to interpret the UNs here? What does UN stand for? UN. Unstructured. It's referring to the places in the G matrix. So G matrix, level 2, random stuff. On the random line we have intercept, and then we have the slope for within person negative mood. So that means UN11 is the first term in the G matrix, row 1, column 1. So that 0.06 is my random intercept variance. UN22 is second row, second column. This is my random slope variance. And 2,1 is the off diagonal. That's my covariance between the two. And day, that's my residual. Whenever you put a variable inside the repeated line, it has that variable's name here instead of the word residual. But that's what it is. So let's say that you have a colleague who hands you this output and says, look at that p-value. It's like 0.06. Is that good enough? Can I keep it? And you say to them, dear colleague, dear colleague. It doesn't matter what the p-value says. You're not allowed to look at it. And by not allowed, I mean there's like 20 people in the world who know and care about this distinction, but you are going to be one of them. Just in case one of those 20 people is your reviewer. Why can't I use this 0.06? Variance can't be negative. This is a walled test for whether or not my variance is different than 0. So that p-value is based on the idea of a two-sided sampling distribution around my variance estimate. But the negative side is going to hit a wall where 0 is. It can't go that way. So a symmetric sampling distribution characterized by two standard errors on either side of the estimate is not going to hold for numbers that can't go negative. And it will the problem will be exacerbated the closer it is to 0 and the more you want to know about the p-value. So dear colleague, I'm sorry no one's told you this, but you're not allowed to use walled tests for variances. Instead, you shall ... Somebody besides Lucas. He's had his turn at bat now, but thanks for playing so much. I heard some other... I heard it. Say it louder. Likelihood ratio test. Yes. Indeed. So here's my -2 log likelihood from my current model. Here's my little fit test macro that compares it to what it used to be. The difference, degrees of freedom difference, is 2, right? Because I have added my random slope variance and its covariance with the intercept. And the difference here for 2 degrees of freedom is a -2 log likelihood change of 2.9 with a p-value of 0.23. So did my model get significantly better, non-significantly better, significantly worse, or non-significantly worse? Non-significantly, right? There's the first part, right? Non-significantly better. Whenever you add something, you're asking if it got better. So it got better a little bit. It got better by 2.9, but it needed to be better by like 6 to be significant. That comes from the chi-square distribution with degrees of freedom of 2. And even if you're using a mixture chi-square, that critical value is 5.1. This is well under it, so no. So this new model that allows this variance component and this covariance doesn't fit better. In English, what does that mean? What do we conclude? Start calling on people. Yeah. What do we conclude? The fact that my likelihood ratio test was non-significant, the model adding a random slope variance and its covariance with the intercept did not fit better, means, in English, yes, no between-person slope differences, no between-person differences in the within-person effect of negative mood. So yes, in result sections, you always want to give the stats, but then there's always the comma, and then such that, or indicating that, right? And that's the part people will highlight, so you got to give it to them. Such that there were no individual differences in the within-person effect of negative mood. People did not need their own slopes for reactivity. Now, do you remember what I told you the story was at the beginning here? We're going to look at the effects of negative mood and how those relationships are moderated by gender. Ruh-roh. So this is where I would say there is a diversity of opinions in the field as to what one should do next. Some people say game over. Some people say game over for testing moderation because you don't have any individual differences. So how can you find predictors of something you don't have? That's step one. The answer to that is true. However, I may not have enough power to find a level 2 random effect to something, except I have 200 people, so shh. But answer 3 is, I'm going to go ahead and test it, and I may have a third kind of effect that we talked about briefly that's a middle ground between fixed and random. Remember what it was? Yes, systematically or non-randomly varying. It is possible that people don't need their own slopes for negative mood, but that men need a different slope on the whole than women do. The slopes may vary systematically as a function of gender, but not randomly otherwise. That is a possibility. So long as you don't need the random slope in the model, theoretically it should be fine to go ahead and test moderators. And this is a paper I have currently under review looking at this. So long as your random slope variance is either non-significant or below some threshold for effect size, 20% for Rimmel or 15% for Emmel, it is okay in terms of type 1 error rate for the cross-level interaction to go forward. Now, given that I simulated these data, I know the right answer. I didn't put a random slope in, and I didn't find it. Amazing how that works, right? When you know the right answer and you fit the right model to it. So I know that it's okay to do in this case. But in life, yes, you may have to fight about it with people, but if you don't have a random effect, some people would say that means you can't go forward, and other people say that you can. I'm one of the latter. So I'm going forward with a model that tests the hypothesis that the study was interested in without the random slope. So here's my equation. Model 2C here is where I'm at. That is page 4. There. So I've written this equation kind of funny. I've left some holes in beta 1, but I did that on purpose because I'm trying to highlight as much what is there as what isn't there but could be. So we have our fixed effect of within-person negative mood. That was significant. We kept that in. We had tested a U1 term for this. It was non-significant, so I took it out. And now I am adding an interaction between gender and within-person negative mood. That's the gamma 1, 2. I left a space here for what would have been gamma 1, 1 because that would have been an intra-variable interaction. That would have been person mean negative mood by within-person mood. I could have added that, but we're not ready for it yet. Moderated by gender is enough for today. The intercept, on the other hand, does have person mean negative mood as a main effect. Main effects predict the intercept here at level 2. It has a main effect of gender, and it has person mean negative mood by gender. That's a two-way interaction among level 2 variables, and so that goes on the intercept line. And it is the third term predicting beta 0, which is why it is gamma 03. So if we were to map the gammas to the words here, play Map That Gamma. It's the newest game show sweeping the nation. Said no one ever, right? So gamma 00, that one's not in here. What's that one? Intercept. It is in there, but we don't have to write it. It's default. You can actually take it out if you wanted by writing no int. And in certain models, like multivariate models, I will do that. But it's there by default. So what is then gamma 01? This one right here. Gamma 01 tied to mood with a bar over it. Teresa, what do you think? Gamma 01 tied to mood with a bar over it. Which word down here does it go with? Person negative mood, indeed. How about gamma 02 tied to my gender variable, which I have labeled woman because that's what the 1 is. Men are the reference 0. Gamma 02, which word down here does that one go with? Yep, that's the main effect of gender. And gamma 03, tied to mood with a bar over it and gender? Yeah, that one. Then if we go down here, which I've already told you is the within person effective mood. Trying to help, trying to help. Gamma 10. This one, and then woman sitting here by itself. I'm pointing at my laptop. That doesn't do you much good. Woman by itself. You're like, huh? We already did the main effect of gender. But this is the interaction term because, yeah, it's going up to beta 1, which goes up to multiply that. So that's a cross-level interaction between gender and within person negative mood when you fill in for the betas. If I had had mood by a woman, this interaction term here down on the beta 1 line, that would have been a three-way interaction between, within, and gender. So I would have had to have added this one as well. That's a whole lot of subjunctive for one sentence. I would have had to have had it added. Yes. By the way, I asked my husband about that whole macabre thing. And he said it with a tiny little rolled R at the end. And we had to ask the Google about this. Apparently there are alternate pronunciations based on where you are. And I couldn't put the tiny little R. But I was reading a story the other day and I came up with another one. Up until I was probably 20, it was apropos. Do you know what apropos is? Anyone want to correct me? You're smiling. What's apropos? Apropos. And I accepted that. I never once questioned where the S went, so I apologize for questioning where the RE went on macabre. Apropos. If you're like an 8-year-old reading, if you're hooked on phonics, right, it's apropos. It just is. It might be apropos, but it's certainly not apropos without the S. I digress. Yes. All right, what are we doing here? Losing our minds. So, are you with me? So the notation and the code is making it seem harder than it is, but all we're asking about is, does the effect of being grumpy depend on if you're a dude or a chick? That's what we're asking. Where being grumpy is two ideas though, being a grumpy person or having a bad day. Yes, a gentleman or a lady, a dude or a chick. Whatever synonym you feel like saying. I do not mind. So to know what these fixed effects mean, we have to keep in mind who our reference groups are. So I know in advance here, both of my interactions are significant, so I have to talk about them. My reference for gender is men are 0, women are the 1. So the intercept of 4.9 here, that's my glucose for an average grumpy man when he's having an average day. My main effects of level 1 within and level 2 between negative mood, those are now simple main effects or conditional main effects. They are specifically for what kind of person? What are they conditional on according to my model here? They're each part of one more interaction term. Conditional on gender, which means they are the effects of negative mood for which gender? The men, the 0, the 0. So it always depends on how you've coded it, but it's for the 0. So in men, we have significant positive main effects at level 1, which is the 0.03, and at level 2, which is now about a 0.2. So men, for every unit more grumpy you are than some other man, your glucose overall is higher by 0.2. And when you are 1 unit more grumpy than usual, that's within person, your glucose the next morning specifically is higher by 0.03. Now let's go to the interaction terms. They both have the same pattern. So let's go this way. Two-way interactions always have 2 possible interpretations. Let's go gender as the moderator, since that's how the story is framed. We just said that men have a significant positive within-person negative mood effect. So negative mood, being grumpier than usual, is bad for them. What does the interaction tell us? Which pattern is this? The interaction makes that positive main effect what in women? Yeah, it's definitely less positive, and it's even heading slightly into negative territory. So the interaction tells us that the within-person negative mood effect that was positive in men is significantly less positive in women. So it was significant and positive in men. It is significantly less positive in women, such that if you added those together, 0.03 minus 0.03, it would be close to 0 in women. Do we know if it would still be significant in women? Just from adding together those numbers? I'll rephrase. Do we know if it's still significant in women yet? No, we don't. But could we find out? Sure we could. Could I make you write like 70 or more lines of code to find out? Sure I could, but it only takes 1. Yes, we can find out what it is in women. Now, I'm guessing that you're not going to write significantly less positive in a manuscript, right? That's not a very friendly term, but that's the pattern. Yes, so Brittany, what would you write instead? How would you put that into more reader-friendly terms? Well, is it making the effect stronger or weaker? Weaker. So that's one way. The effect was significantly weaker in women. I'll take that. Less something, if you're heading towards 0, less something, less positive, less negative, that means weaker. So that's what I would do. After I identify the pattern in terms of my 4 kinds, more positive, less positive, more negative, less negative, then comes putting it into English. So yes. The pattern of reactivity within persons found in men was significantly weaker in women. How's that? Semicolon, it was, and then this is where I would report what it was in women. Cheating ahead, I have that down here. Here's my estimate statements. Non-significant in women, just barely away from 0 as you might expect. Likewise, here's my between person effect of negative mood in men. It becomes significantly less positive in women, significantly weaker. Is it significant in women? I don't know. We can find out. And if we go the other way, here's my gender effect. It's non-significant. So can I just say, there was no significant gender effect, the end? Can I say that and be done? This is, see? No significant main effect of gender, the end. Why are you giggling, Scott?
Usually, if you say it that way, it probably means the answer is no.
That's correct. What might one need to add to make that answer more correct? Do I have a main effect of gender possible in this model, given the way gender is included? Gender effect for whom? For what kind of person? That's my gender difference among what kind of people? So we're going the other way on the interaction here, folks. You told me that the within and person mean effects of negative mood were specifically for men because that's when their interacting variable was 0. We're going the other way now. The gender difference is specifically for average people, average grumpy on an average day. There are no gender differences when people are at their average and if they're of average grumpiness. However, let's go this way. Let's go simple main effect of gender. So women have lower glucose non-significantly in average grumpy people. That simple main effect of gender that's negative becomes what as grumpy increases? Significantly, we got that one. Yeah, which pattern is this? Same sign. So that's a more. And what is the sign? Hey, significantly more negative. Now it's hard to say there's a more negative gender effect, right? That's like there's no obvious up or down on that. So if I'm going to rephrase that, I might say something like, because because glucose is bad for you, right? Is that right, Amy? Glucose is bad. So the glucose advantage favoring women was exacerbated, was stronger, was bigger, was something, more bigger, was more biggery in people who are more grumpy. More biggery, you heard it here first. And the same pattern when people are grumpier than usual. The gender effect is more pronounced. How's that? Ooh, I like that one. Let's go with that. Pronounced. See. The advantage favoring women, I'll call it that. That's what a negative effect of gender means in this context. And it's actually not negative in the real world sense because glucose is bad for you, which means having less of it is better. So a negative effect is really quite positive, right? Yeah, that's why positive and negative effects are those words, unless everything goes in the same direction. Yeah. So the end of the story is yes, the effects of negative mood are more pronounced in women, or excuse me, in men than women. I can write estimate statements to figure out what they would be in women. So I have some here for you. So the intercept, I'm leaving off the negative mood variables, so I'm holding them implicitly at 0. But this is another way of saying the conditional mean for average grumpy. That's what it would be for men. The intercept plus the simple main effect of gender is what it would be for women. This by itself gives you the gender difference. Same pattern for all of the other terms. Whatever the effect is, that's the thing that gets the 1. And then we fill in the value for the moderating variable. So if I want the within person effect for men, I fill in a 0. If I want it for women, I need what would it be for women, or excuse me, for men, and then how would it differ for women, and then how it differs is just the interaction term by itself. So of these lines on here, these ones, how many do I actually need to write? How many are not redundant with the output I already have? The ones for women are not redundant, the differences are, because the differences are given by one fixed effect. So the only lines that are not redundant, the ones that I really do need to write, are the ones in which there is more than one value given, the ones where there's addition that's required or subtraction. But like I've said before, writing them out, even if they're not necessary, when you go to look at this 2 years from now and you want to figure out what the heck you did, those words are going to save you. Or if you want to send a table of output to somebody else, or make a table for your paper, the words will save you. Contextual effects. This is how you ask if the difference of the between and within effects differs by gender. We'll get there next time, it looks like. But those are other things that one might be interested in. So here's the full set of results. And here is a picture that I made within, here's how I made the picture in Excel. I copied in the coefficients, and for ease of formula making, I dragged them down. I went plus or minus 1 standard deviation for each of my mood variables, and it actually worked out that a standard deviation in each was close to 1. And so I have -1, +1, -1, +1. That's average is 0, so I'm omitting that one. So I have a low grumpy person and a high grumpy person. And then I have -1, 0, 1, meaning a lower than usual day, an average day, and a grumpy day. And then I have that for each level of gender. And then there's my formula. Intercept plus slope times variable plus slope times variable. And I just draw the formula over here so that Excel understands that I want to make a picture. And there it is. So if we go through the picture, note that I have done one of the things I always yell at people about, just for the sake of making the lines easier to tell apart. This y-axis is cheated. You should probably plot plus or minus 2 standard deviations of the outcome scale to make it fair. But since no one knows what the hell a log is anyway, I'm going to take some liberties and just blow it up and make it look like my effects are ginormous. So I have women in red and men in blue. So I have one line for each distinct combination of gender by person, mean, grumpy, and I have labeled them accordingly. Happy man, happy woman, grumpy woman. And the x-axis, sorry, after a while I just lose all powers of speech here. The x-axis is within person negative mood, where the middle is when you're at your average, whatever that happens to be. So then the slope of these lines tells me what? The change in glucose based on previous day's grumpiness, yes, otherwise known as the within person effect. At level, here's your next softball. Within person effect at level 1. There we go. So the blue lines have a positive slope because the men had a significant within person effect. The red lines have a 0 slope. The women did not have a significant within person effect. Do we know if the slope of the blue lines is different than the slope of the red lines? Do we know that? It looks like it, but do we know that? Can we say that? Is the slope of the red lines different than the slope of the blue lines? Nope, I'm asking, it looks like it, but I don't go by visual analysis in this class. We do actual analyses. So, yeah, she went there. And my actual analysis is right here, folks. Within person effect difference. That's my interaction term. That's my gender by within person negative mood interaction term is the test of whether those red and blue slopes are different, and indeed they were. So there is a different within person slope in men than in women. Now the differences vertically between the lines. What term in the model is responsible for that? It's the term that differentiates happy from grumpy. As a trait. That's the between, that's the person mean. So within a gender, the solid line is the grumpy person, and the dashed line is the happy person. So the grumpy people are higher because glucose is bad for you. But if you look at the difference of those differences, the blue lines are further apart than the red lines. So being a grumpy person is more bad for you if you're a dude. If you are a woman, it is not as bad. No badder. It's no badder. Okay? No badder. Yes, and that's the between person effect is the differences between the lines. The difference between the blue lines is the between person effect for the men. The difference between the red lines is the between person effect for the women, and the difference of those differences is the gender by between person interaction. Whew. Now there's some of these lines are parallel, right? Because what don't we have in the model that would make all 4 of the lines have different slopes? Another slope, yes, specifically what don't we have? Interaction, I heard it. A 3-way interaction between, within, and gender would make either, okay, I gotta say this right. It would make the gender difference in the within or between effects contingent on what kind of person you are or what kind of day you're having, respectively. Basically, it would allow for the effect of person, mean, and gender to interact uniquely. Say that might be a little bit easier, but it would render the lines completely non-parallel. A 3-way interaction. But I did not do that for you because this is enough. Don't you think? This is enough? I think so. So with the 1 minute we have left here, I'm going to be reviewer 3. I don't understand why you have mood in your model twice, and I think that it's collinear and bad, and you're wrong. Because collinear. That's a common one, right? Dear reviewer 3, what do I say? Why do I have mood in my model twice? And do I need to worry about collinearity? Or multicollinearity, as it is sometimes called. I'll give you a hint. I wouldn't spend the last hour and a half showing you how to do something wrong. That would be really mean, wouldn't it? Dear Reviewer 3, we apologize that our description of our modeling approach was not sufficiently clear. There's your start, right? It's your fault when they don't understand what you did. As now clarified on page 12, how do I explain this? Andrew, give it a shot.
You could say that the one variable of negative mood is the partition to reflect the separate differences between variables that are actually one.
Yes, the one variable we started with, time varying negative mood, has been partitioned into 2 new variables that are uncorrelated, orthogonal, uncollinear, whatever term will make that person happy. And we need both because one represents state differences in mood, day-to-day fluctuations, that's within at level 1,